Hello students, in this video we will discuss problems on limits. This is one important concept. Frequently one or two questions will come JEE Mains, KSET and MSET in different examinations. So I will recall briefly the definition. Suppose f of x be any function as x tends to a, x is approaches to a, its corresponding function f of x tends to L. The x tends to a, f of x tends to L. Then this L is called limit of f as x tends to a. Symbolically we should write limit x tends to a, f of x is L. Simply we should write. Now one point I will tell, important point, limit exists. Limit exists. I will take one point on real line. This is a point A. Suppose x values are approaches to right of A. That means every x value is greater than A. In this case we should write symbolically x tends to A plus. X tends to A plus indicates what? X value is greater than A. In this case, suppose f of x tends to L1. L1 is a number, finite number. F of x tends to L1. Therefore, limit x tends to a plus f of x is equal to what? L1 according to definition. This is known as right hand limit RHL. Limit x tends to a plus f of x is equal to L1. X tends to a plus indicates a plus means not only positive. Okay, this indicates what? X values are approaches to right of a, that is just greater than a. Okay, again suppose x values are approaches to left of a. In this case, very clear, x is less than a. X is lesser than a. How to write? X tends to a minus. X tends to a minus indicates x values are approaches to left of a, just left of a. Okay, in this case, limit x tends to a minus f of x is equal to, suppose L. That means f of x tends to L2. X tends to a minus f of x, its corresponding function. F of x tends to L2. Okay, this is called left hand limit. Okay, right? Now suppose these two values are equal. That is, left hand limit is equal to right hand limit. In this case, limit existed at that point. So how to write common value like this time? Limit x tends to a, f of x equal to L, where L is the common value for left hand limit and right hand limit. Okay, this is the concept of limit exist. In sometimes both limits will exist but not equal. In that case, limit does not exist. Okay, exist means what here? The corresponding function approaches to some finite value. Okay, right. Now one example I will give. Let f of x is equal to mod x by x. Mod x by x. Now identify limit x tends to 0 mod x by x. Limit x tends to 0 mod x by x. Here observing here x tends to 0. Then mod x by x tends to what? Okay. Here mod x is a part of the function Everybody knows mod x is equal to x, where x is greater than or equal to 0, minus x, when x is less than 0. Okay, and now observing here, first we should calculate right hand limit. Limit x tends to 0 plus mod x by x. X tends to 0 plus indicates x values are approaches to right of 0. That means what, x is greater than 0. When x is greater than 0, mod x is equal to what? X. That's why very clear, limit x tends to 0 plus, this is what, x by x. But I can say that is equal to what? 1. So as x tends to 0 plus, the corresponding function tends to 1. Okay. Again next. Observing left hand limit, limit x tends to 0 minus mod x by x. X values are tends to 0 minus indicates what? X values are approaches to left of 0. Left of 0 means x is less than 0. When x less than 0, mod x given by minus x. That's why very clear, limit x tends to 0 minus mod x means what? Minus x. So finally what? Minus 1. Very clear, observing here, as x tends to 0 minus, the corresponding function approaches to tends to minus 1. So both limits existed because in both cases the corresponding function tends to finite number but not equal. That's why in this case limit does not exist. So very clear, that implies limit does not exist. On basic problem I given. Here in this topic here, different types of the functions are there and some different techniques are there. So model wise we will discuss now. One basic method I will explain now, that is L'Hospital rule. This is a very important rule for solving. Here observing L'Hospital rule. Generally this method you should apply in 0 by 0 form or infinity by infinity form. Both forms are known as indeterminate forms. Both are called indeterminate forms. That means no value. In that case here, f of x tends to what? We can't say. In both cases. So this technique is very useful for identifying the given function tends to what? According to the given point. Okay, observing this problem. Let f of a equal to 2, f dash of a equal to 1. G of a is equal to minus 2. And g dash of a is equal to 3. This is the given data. We want limit x tends to a. Then this function approaches to what? As x tends to a, this function approaches to what? First, primary observation. What's the primary observation? Here, x tends to a, replace x by a, what happening? So, g of a into f of a minus g of a into f of a minus a. This is 0, this is 0. Finally, this is what? 0 by 0 form, no value. That's why here, simple method here, limit x tends to a, just we should differentiate numerator, denominator separately. Just using differentiation concept. Okay. Now the derivative of g of x is g dash of x into constant minus g of a is constant and derivative f of x is f dash of x divided by x minus a derivative 1. Now we should again replace x by a. X is tends to a, near to a. Very small difference between x and a. So replace x by a, what happening? G dash of a, f of a minus g of a, f dash of a. Both are not same. And denominator is what? 1. So here this form won't give 0 by 0 form or infinity by infinity form. So no problem, you can stop the process. So in case After replacing x by a, again 0 by 0 form will come. One more time, we should differentiate numerator, denominator separately. That's all. Okay, right. You're observing what happening. Replace x by a. G dash of a into f of a minus g of a into f dash of a. Very clear. What about given g dash of a means 3 and f of a means 2 minus g of a means minus 2. F dash of a is what? 1. Very clear. 6 plus 2, 8. So as x tends to a, according to given data, this function tends to 8. Understood? Right. One more question we'll discuss. Let f of x be twice differentiable. F of x is twice differentiable and f double dash of 0 is 2. Okay. And limit x tends to 0, this function tends to what? Or approaches to what? Okay. Here what is given here? F double dash of 0 is 2. Right. Now, first primary observation. Replace x by 0, what happening? 2 into f of 0, 3 into f of 0 plus f of 0. Very clear? Everything cancellation, 0 will come by 0, 0 by 0 form. So, we can't say its value, this function approaches to what? That's why should apply LHospital rule, that is differentiate NR and DR separately. What happening? 2 into f dash of x minus f dash of f of 2x derivative. F dash of 2x and derivative of 2x 2. 3 into 2, 6 plus f of 4x. So f dash of 4x and derivative of 4x is 4 divided by 2x. Again just the primary checking now. Replace x by 0, what happening? 2 into f dash of 0, 6 into f dash of 0 plus 4 into f dash of 0. All terms will cancel. Here 0 will come. Again 0 by 0 form came. That's why again one more time we should apply. Differentiate NR dr. Limit x tends to 0, 2 into f double dash of 0 minus 6 into f double dash of 2x into derivative of 2x 2 plus 4 into f double dash of 4x into 4 divided by 2. Now very clear here, denominator is finite number, that's won't come this format 0 by 0. Now replace x by 0, what happening? Observe. Okay, 2 into f double dash of 0 minus 12 into f double dash of 0 plus 16 f double dash of 0 divided by 2. Very clear. Here f double dash of 0 is given by 2. Now I should simplify this one. 6 f double dash of 0 by 2, or this value is 2. 6 into 2 by 2 cancel 6. So as x tends to 0, this function is tends to 6 when f double dash of 0 is 2. This question is already given in JEE. Okay, remaining problems we'll discuss in next video.